Hello. So, hi everybody. This talk it's on the Play Integrity API. The idea is to give you a full overview of the API, so you are going to get out of this room with a complete understanding, and so you can trust me on this. That's the problem. So I'm Pietro Maggi. I work in Android Enterprise as a TSC, is a technical solution consultant. So I'm a consultant, so I don't really know if you can trust me. I like to take things apart to understand how they work. And if you are asking yourself, what is Android Enterprise? It's not a different version of Android. It's simply a set of features that we have in the Android, both in ISP and part in GMS core, that takes care of the security of the operating system. We have an API to manage the device, so if you need to set up multiple devices, this is very handy. We have the work profile, so if you have an Android device from a company and you have personal work profile, this is the kind of things that my team builds. And we try to make it fun to use, so for example, you can turn off the work profile during the weekend so you don't get any notification, any email from the work application. Today for the Play Integrity API, I'm going to cover this agenda. There should be time at the end if I time this correctly. Otherwise, you can stop me or my colleague that is working on the API. So we are going to cover what is the Play Integrity API, first of all. The idea is that the Play Integrity API is to cover, is to guarantee that your backend, so the request that is hitting your server, is coming from a trustful source. So it's checking for the authenticity and the integrity of the request that you are receiving. So this is important on this point. So the Play Integrity API is done with the goal to guarantee that the information and the value that you have on the server side is protected. So that who is hitting your API is not a Python script, is not a corrupted version of the application with some additional malware, and so on. So the QR code you're going to see on some of the slides are the links for different part of the documentation or tooling and so on. Okay, the idea is that you need to have a strategy, an anti-abuse strategy, and also have an appropriate secure practice for your application. For the anti-abuse strategy, I'm talking today about the Play Integrity API. Is not the only solution for anti-abuse. So it's one part of a solution. In these 2 days, there are different companies with booth talking about security, how to protect application, and all of them are using different signals. So the Play Integrity API is one of the possible signals that you have to guarantee that what is hitting your backend, it's a real device, it's a real user. And security practice, well, it's mostly because of user trust. User trust is something that takes a lot of time to build, but if you have an accident, if you have a security incident of your application, it's very quick to lose all the user trust. So it's very expensive to have a security incident. Okay, how this works? We are going to talk about this attestation verdict. So if you have familiarity with the safety net attestation, the Play Integrity API is the next iteration of this API. All start with the idea that, okay, a user wants to do an action on your backend system. And this is really, for example, you have a financial application, you want to do a payment, or you have a game, and you want to, for example, buy some additional coins or other, whatever you use in the game. And the idea is that this is the start. Okay, you want to protect this request. The app requests a Play Integrity API verdict to ask for an assessment. The play return a verdict on about the device, the application, and the user account in this case, the play account. So it's not just about the device. So you are going to get an information about how much trustworthy is this device. It's rooted, it's up to date, and so on. About the application, we are checking the application is not being tampered. And the other things is that we are giving information about how much trustworthy is the play account that the user is using. And at the end, you are never going to have, in most of the cases, it's difficult that you get a full green line on all the 3 different signals. There are different levels of trustworthiness. You can have an older device with some vulnerability, but you decide that for that particular request, it's good enough. So it really depends on what you are protecting at that point, and it really depends on your business logic at that point and the action that the user wants to do. And okay, so this is the goal. How do we achieve this? There are 2 different ways to request a verdict from the Play Integrity API. The classic request, that is very similar to what we have in safety net attestation, that takes a few seconds to run, and you can use, for example, when it's very critical to certify that the user is a real user, a real device, and so on. And then you have the new standard request. This is still in beta, but the idea is that this is a low latency version of the API. So the major comment, the major feedback we got on the classic request was the time that it was taking to do an assessment of a device. The standard request, and this is why we are calling it standard, want to solve this problem. We solve this problem splitting the request in 2 phases. You have a setup phase where you warm up the API. If you want, you are going to build an object that you are going to then use on the critical path when you want to get an attestation, when you get to have the verdict on device, account, and application. At that point, you can call the object that you created in the initial part. Classic API request, as we said, everything starts from the server. So in this case, the classic request, because the API is intended to avoid replay attack, it creates a nonce, so a unique value that is going to be used in the life cycle of this request. The idea is that you get the nonce from your own server, you do a request, you get a token, you pass back the token, and the Play Integrity API on the server side. So the Play server returns a token payload. The token payload includes also the nonce, so your server can check that, okay, this is the request, was the nonce at the start, is the same nonce, so is the correct request, and then you do a decision on the server side. Can I trust this API request or not? The standard API, as I said before, is split in 2. So we have a first phase where we warm up this standard token provider. And then each time we need to have a verdict, an attestation verdict, we call this with a request hash. The request hash is similar in the goal as the same goal of the nonce in the classic request to avoid a replay attack. The request hash is practically a hashing of the most critical information inside your API request. Imagine that you are asking to buy some coin in a game. It's going to have the information about the account that you are buying, the amount of money, how many coins, and so on. There is a limiter, I think it's 500 bytes that you can put in for this request hash. The important thing is that you want to keep there the relevant information to avoid a reply attack, because if you don't put there the amount of coins that I'm buying, maybe I resend in the same request hash with a greater value of coins, and for the server, it will be still valid. So it's important to what you put inside the request hash. Obviously, you want to have a real hash there, not putting clear information, because otherwise it's could be a problem. And then you get back the token, and it's very similar to the classic API request. The token goes to the play server. You get back the payload, and the server makes a decision. The idea is that in this scenario, the on-demand part on the critical path is going to take much less time than the classic part. So it's less expensive to use this. You can use it more frequently. What is in the integrity verdicts that your server side is going to receive, that you're going to receive from the API? 4 different information. So the request details, that for the classic request is going to be an enhance, and for the standard request is going to be the request hash. The app integrity, so information about the application, the device integrity, information about the device, and account details, having additional information about the play account. Okay, exactly as you see. I knew it. I'm a consultant, so you can trust me. How you do the device integrity? Device integrity, by default, gets the value of meet device integrity or a null. So if it's not meeting the device integrity, you don't get back any value. In the Play console, we are going to see later that you are going to set up the Play integrity API. We suggest to set up in the Play console. There is the option to enable 2 other values, and we suggest to enable them because you get additional information from the API. So you can enable also the meet basic integrity and the meet strong integrity. The idea that meet strong integrity guarantee you that the Android device is powered by Google Play services, and there's a strong guarantee on the system integrity, such as an hardware-baked trusted environment. So there is a full chain with the trusted environment certifying that the bootloader has not been compromised, that the image is a valid image certified by Google, and so on. So we are certifying the full chain on the device. Meet basic integrity, this is not certified. It's not possible to certify on this device. It's not because the device is not with a locked bootloader, for example, but maybe there is some issues with this trusted environment, or it's an older device and doesn't support some of the functionality that is required by the strong integrity. So you can expect that you are going to have a percentage of your users that are able to meet the strong integrity, and a larger user base that can meet the basic integrity. So it's up to you. It's one of the decisions you need to take if you want to trust this device or not, depending on the value of the transaction that you are doing on the server side. Again, this is something that you can enable, and we suggest to enable, so having these 2 additional information. Let's see how you set up the API, so both on the backend and the mobile application. The setup, there is also another action. So you set up the Play Integrity API on the Play console or on the GCP Cloud console. It's probably easier to do this in the Play console. One other thing is that because there is a server request going to the Play server, there is a quota that we are providing you when you call this API. The default quota is 10,000 users. And it's more than enough for testing the API during development. If you need a quota increase, there is a form, you can fill out the request. There is no cost associated to increasing the quota. simply that takes a few days because it needs to be manually evaluated and approved. So it's, the suggestion is that if you don't wait the last minute to ask for a quota increase, otherwise it's going to hit you a bit. The other thing is that because there is a server side involved, plan also for outages. So we don't plan to have outages, but things happen. So there may be a moment when you call the API and the API is not available. So if that, it's up then to your backend to decide what to do in those cases. If showing a message to the user saying to reply later, or accepting the transaction because it's not a huge cost if it's a malware at that point. For the backend, it's depending on which kind of request you want to do. For the classic request, you handle the generation of the nonce and then the verification. And for the standard request, you handle the checking the request hash for the standard request and all the logic around the decision outcome. The mobile application, depending on how you build the mobile application, we support Java, Kotlin application, we support Unity for games, and we support a native application directly. So how you enable the Play Integrity API, I'm showing here how you do in the Play console. There is an option available in the Play console. I don't know if you ever see that it was there. You can enable there, and below I put the screenshot of how you enable the meet basic integrity and the meet strong integrity. So you can enable one or both of them. As I said multiple times, suggestion is to enable this and getting additional information. The quota, it's 10,000 requests a day, simply to avoid DDoS attack to our servers. We have all the API with quotas, and you can request a quota increase. Okay, for mobile Java and so on, starting point is to include the library. You need to have at least version 1.1 to get the standard request. The latest version is 1.2. And the idea is that you can also use the API with native. And for having the standard request, you need to have at least the Play Integrity, the Play Core native SDK version 1.12.1. And for Unity is the Google Play Integrity plugin for Unity version 1.1 or higher. So this is how you integrate them, and you are ready at that point to call the API. I'm going through the standard request. This is the low latency use case. I think is, given the feedback we got on the time that it takes a classic request, I think is the most relevant. We can talk about the classic requests if you want, but it's very similar to what you had in the safety net attestation. So it's a two-step with the warm-up and the request, and then you can decrypt and verify also on the device. So before you make the standard request, you need to build this, integrity token provider. And how you build the integrity token provider, it's using the standard integrity manager, you build a new integrity provider. Because there is a server component included, this relies on the presence of a GCP project. And the next step is to construct the token request provider. You need to pass the the cloud project number that you are using for the verification. And the last step is to request an integrity verdict, and this is something you do on demand on the critical path. You use the standard integrity token provider to request, and you see that the parameter you need to pass here is the request hash. Never going to find it. Okay, here is the request hash. Okay. as I said before, never put any sensitive information as plain text into the request hash argument, because it's not calculating for you the hash. You are supposed to put there the hash already. So if you put there the information, a network analyzer, so if you sniff on the network, you can see what are the parameters. Okay, you do the request, you decrypt and verify the integrity token. So you get the integrity token in GCP. You need to have this service where you grant two roles to the service account, so the service account user and the service usage consumer. And on your application server, you fetch the access token for your service account credential. And you use the Play Integrity API scope. And then you read the JSON that you get back. The resulting payload is a plain text token that contains the integrity verdict, the 4 different parameters we saw before. So you can decode the integrity token and extract the request hash. And so you check that this is the same request that you did at the beginning. So it's not a reply attack. You compute the digest of the request. And so if they don't match, okay, there is a problem. Regarding the analytics and see the usage of the API, inside the Play console, you get the possibility to see the reporting on how many calls and the result of the calls. So how many, in this case, how many meets the device integrity on the device, how many are licensed. So for example, you in the user account information, if it's a paid application, you also get the information about if the user has a license to run this application. And the last part, it's about the test and errors. Okay, how you test the API. There are different ways to test the API, starting from the device. You can check having a test device, you see that you have problem on a particular device. There is a debug option in the Play application on the device. Similar to what you need to do to enable the developer option for Android, you can enable the developer option for Play. You go on the settings, the information, you tap 6 times on the information on the version of the Play application, and you have an additional menu with the debug, a couple of debug options. Enable the application sharing and asking for a Play Integrity API verdict. And when you ask for a Play Integrity API verdict, you get the information of the device. So this is a real information that when you call the API, this is what is coming back from a standard request or a classic request. So you get the integrity verdict, the device details, a test ID. If there are problems on the API, and this is an information that you can pass us to debug. So you can open a bug on the issue tracker for the API, and the information is going to help us to understand, to check on our logs the request and so on. Is, for example, the package name of your application. But also, if you have the test ID, it's going to help us identify the particular request. Then you can test the Play Integrity API response for your application in the sense that you can enable in the Play console a few test accounts. So you assign particular account emails to a specific request, to the standard request or the classic request. Imagine that you have you want to test the failing of the request that is telling you that the device is compromised. Okay, you can set up a particular device, a particular account, and setting that request in the Play console. You are going to get back the JSON with this additional parameter, this testing details that is telling you that this is a test answer. So just to identify this clearly. And then the error codes. There are two different set of errors for the classic request and the standard request. The most important are, for example, if you get an API not available, -1. So there is an helper function that you can use to go from the number to the code and having an error message. The basic idea is that if you get the API not available, it's probably because the version of the Play Store on the user device is not up to date. So one thing that we have seen is that in some cases, if the Play Store is not up to date because the standard API for the standard request API, it's a new API, it's not available on very old version of the Play Store. So you need to have an up-to-date version of the Play Store, at least a 2023 version of the Play Store. So it's getting better over time, but especially at the beginning with the API still in beta, this is an option. And so you can, for example, the mitigation in this case is to suggest the user to update the Play Store. So opening the Play Store, so they can update it. Place not found, it's maybe it's a custom ROM or some device that comes without the Play Store. It happens. Network error is probably one of the most frequent, maybe together with another one that is let me see if I have the transient error. Transient error is my favorite. Network error, it's practically you have some network on the there is some communication error. There is also a request throttling on the device. You cannot do more than 5 requests a minute on the device. And also, if you have a network error, those are counted in those 5 requests. So the suggestion is always retry. Don't retry too soon. Do a exponential backoff. So you retry after a few minutes, and you increase the amount of time, and you increase, and so on. Transient error, you retry. It's the funny error. Is the quantum error. I don't know, in the sense that we are working to improve the API. We are working to provide more information. We have a class of errors that we are still working to nail how to report to the user, and in this case, we are returning this transient error. Retry logic, in this case, is really about giving a bit of time, I don't know, 5 seconds, and then you want to retry after 10, 20 seconds. Obviously, if you have a network error, and you know that there is no connectivity, it's really difficult that the API is going to work. So, but it's also funny to understand how you can do a server request. The problem with connectivity is always that you check the connectivity, you have it, you do the request, the connectivity is not there anymore. It's a quantum connectivity again. Okay. So if you continue to see the error after 3 times, you need to have some strategy to tell the user that it's not working or retry later and so on. Safety net attestation. I'm curious, how many are using safety net attestation? Okay. Interesting. I was expecting a bit more. Well, it's good because it's deprecated, so you need you should upgrade. We have a deprecation notice. The good part is that if you are using the safety net attestation, the classic request is exactly the same. It's very similar. You have a similar logic with the nonce and everything that is going on. And on top of it, with the Play Integrity API, we have the option to do a low latency request. This is the timeline for the deprecation. So we are trying to give as much time as possible. We announced the deprecation last year in June. And starting from this year, we are not accepting new developers on the safety net attestation API. And the important dates, it was June 2023, has been postponed to January 2024, is the time that you need to migrate to the Play Integrity API. If your application doesn't migrate to the Play Integrity API, the safety net attestation is stopping to work. So that's, you are asking for a verdict and is not going to reply anything. By the way, inside the answer that you get at this moment, you get the information that the application is deprecated, the API is deprecated. So in the JSON that you are getting back from the safety net attestation. If your application, if you upload to the Play Store a version of your application using the Play Integrity API, the safety net attestation is going to work for you for an additional year. What is the logic behind this? The logic is that not all of your user may be upgrading to the latest version of an application. Maybe you don't have that level of control, and so we want to give your user an additional year to load the latest version of your application. We are here now. Okay, I was asking why I have this slide. Next step, we have a code lab. At this moment, it's still only covering the classic request. I'm behind on my schedule. But this shows how to integrate the API. It includes the project for the server side, includes a Kotlin project, includes a native project, and a Unity project.